a little tedious. Thank goodness this is in terms of only sine in one variable. And they're asking me to solve this. Now this looks like a quadratic. Also looks like a type that I might suggest something we've done for many other problems in the past. Is this. Just the way it looks. Let U be something. What do you think U would be, what would be appropriate for you here, do you think? To rewrite this? Sine theta? Okay, so guys, if U is representing sine theta, let's write this as 2U squared minus 3U. Look at this, this is mathematics. Now that you've changed into a middle school problem. It will factor, thank goodness, into 2U, U, minus 1, step back to that, looks good. Split this up, I'll do it quickly guys, you're going to end up U is equal to 1/2, we all know that, and U is equal to 1. U is representing sine theta, so I'm not quite finished, so this says sine theta is equal to 1/2. Sine theta is equal to 1. This one's not going to be too bad. It'll be a little bit easier than what you saw before the break. Now, can anyone remind me, I've seen this so many times tonight, where have you seen the y-coordinate sine equal to a 1/2 on that unit circle? 5 or 6, and also 5 or 6. Y-coordinate is 1/2. I know the unit circle. Michael, you're saying I accept anything that falls between 0 and 360. Don't give you a restriction on the end. And these two will fall between 0 and 360. Also, another possibility is where have you seen sine equal to a 1? And I think the only place where the y-coordinate is 1 is pi over 2. And does pi over 2 also fit between 90 degrees between 0 and 360? I'm done. Answers based on what he gave me. I got 5 or 6, 5 or 6, 5 or 2. We have done a beautiful job tonight. I may have worn you guys down a little bit, but we had to do it. We're finished. Let's solve the equation. Now, Michael, part 2. Tell me the first example there I had in part 2. I think you said under identities.
Secant theta
Okay, hang on, I have to get that word out there. Okay, secant theta
times sine theta equals tan.
times sine theta is equal to tan. Okay, guys, we'll do a couple of these. What they're doing here in this last section here is they're going to give you expressions and ask you to please show the two sides are equivalent. Based on something we already know. And they want you to show all the work here. Guys, to show, it's not solving, we're not solving here, the word's not solved. Did I use the word establish?
Mm-hmm.
Okay, establish, not solve. To show the two sides are equivalent, so we'll do it like this, guys. Stick to one side and make it look like the other. Here we go. A nice name for secant. Another way to express secant is, we know, is 1 over cosine. Next to it is sine. And if I stick with that on the left-hand side, I'm down to looking at this. Sine over cosine. And what is sine over cosine equivalent to? As soon as you get this to match up to the other side, you're finished. I'm finished. That's all you have to do. Michael, how many of these did I have down there? 3. Oh, beautiful. What's the next one?
Parentheses, sine plus cosine squared.
Sine plus cosine theta squared. Okay, tell me what.
Plus sine minus cosine squared.
Plus sine minus cosine. And that's being squared, right? Okay, tell me more.
Equals 2.
Let's show it's equal to 2. Guys, you know, try to work on the left-hand side, looks like that's where the work is required, and show that that left-hand side nearly is saying 2. How would I approach this? Many of my students probably see right now what to do. Can anyone tell me what sine theta plus cosine theta expanded out is? Like a plus b squared. What would sine theta plus cosine theta, like an a plus b being squared? I'll get you started. Sine squared, first term. You want to do what the second term would look like? A plus b times a plus b. Whoa. And you know what I mean when I say expand this thing out? You're doing this. And I know there's trig functions staring at you, may scare you. If you're doing this, that's what this means to do. Now, can anyone tell me what that multiplied out to give you? There you go, sine squared theta plus, what goes in the middle? 2 sine theta, cosine theta, thank you. And there's a term on the end. Cosine squared. Now that's just this, guys. Hold on. With his help, that's expanded out for me. Now also though, on that side, I'm putting out space here, you guys expand the next part out. Plus, now here goes guys, I need this expanded out. I'll do this fairly quickly. Here you're going to end up with sine squared minus 2 sine theta cosine theta plus cosine squared. Is that true? Now we group this, guys, this is the first one that I've received some help with. Here's the second one. Those are the expansions done. Taking a close look at the expansions, my goodness, I do see, I think I see, let's put it here. These 2 terms drop out. Sine squared, I have 2 of those, combining like terms. Cosine squared, I have 2 of those. All this is being done on the left-hand side. Now what?
Divide by 2.
You can't divide by 2, you can't work with both sides. For the established, they want you to stick with one side, don't
Factor out the 2.
factor out the 2. Regani in essence is almost the same thing you asked me to do. But I will stick with one side. So factor out the 2. And then all of a sudden, there's that sine squared plus cosine squared, which always is what? 1. And therefore, there's the 2 on the left-hand side, and that matches up with the 2 on the right-hand side. And when you get the 2 sides to match up, you have established it. Okay? You tell me there's only one more. Michael, you? Letter C, read that to me.
Secant theta over cosecant.
Oh, here it goes. Secant theta over cosecant. Okay,
Plus sine over cosine.
that's sine over cosine.
Equals 2 tan.
Is equal to 2 tangent?
Mm-hmm.
This will be interesting for the last one. Here goes, guys. Got to stick with one side. Best we can. On the left-hand side, I'm gonna work on the left. What would you suggest to me to work on the left? What type of work can you do over there?
Common denominators?
If you use a common denominator of cosecant, cosine, I could. You put those 2 fractions together, I absolutely could. You wanna do that? We can do it. Here we go. I'm gonna do that. You suggested. He wants me, guys, to use cosecant theta times cosine theta, interesting, as a common denominator and put those two fractions together. So this one's missing the cosine. Squeeze that in. And the second fraction is missing the cosecant. I mean, we are really getting into this material. Roberto, with your help, here we go. At this point, I have secant theta, cosine theta, plus, geez, what a mess, sine theta, cosecant theta, all over the common denominator. We call it step one. This one's getting a little heavy. You guys agree? He said put it all together, that crazy common denominator. I saw another approach, but Mr. Mathematician knows what to do there. Now what? Can I go from there? Roberto, there's nothing wrong with what you said. Nothing. In fact, I can do more with that. Did anyone see another approach to take? Aaron?
1 over cosine over 1 over sine.
Okay, hang on now, hang on. Now, let me tell you, I see right now, this would eventually work. There's nothing wrong with this. I think it's the time, I'll press for time here. Aaron, you're saying, go ahead and change that in the black there. Seek it quickly into 1 over
cosine.
hang on. 1 over cosine, which it is. And you're changing that cosecant to what?
1 over sine theta.
Beautiful. Another mathematician here. Put a plus sign in between. Are you gonna do anything over here or just leave it?
You can turn into tan.
Oh, you want tangent?
Yeah, tangent.
Which it is, sine over cosine, it'll help me. Maybe put tangent. There's nothing wrong with that. Just like there's nothing wrong with what Roberto was gonna tell me to do. Let's see if this will work. Everything perfect. Like I said. Okay, at least you got a tan. How about this, Aaron? What you got in mind here?
If you count it out, it becomes sine theta over cos theta.
Oh, let's see what it is. Sine theta over cosine theta. We'll show you the class why it is. And then, of course, you still got tan theta on the end. Oh, look at this, guys. Now, why did he say that this was true? What he gave me was 1 over cosine, which is true. It's been divided by 1 over sine. And we know what division means. It's 1 over cosine times, you gotta flip this over. Reciprocal, we know how to do a division. And that would give you sine over cosine. Oh, by the way, sine over cosine then immediately is what, tangent? So I'm gonna call this step 3. He said, hold on, Professor. Sine over cosine, that first term is merely tangent. And plus, we had to change it down here in the second term to begin with. Combine like terms, you end up with this. 2 tangents. And that's what they wanted. Wow. Aaron, thank you. Worked out. And I know yours would eventually work out also. Guys, any concerns there? I'm looking at my time here. Oh, we have too much time for a quiz. That quiz, maybe most students will take about 10 minutes, maybe a little bit longer. Okay. Guys, any concerns here? Tell me this, Michael, did we actually finish up that entire worksheet?
Is it section for 6.2?
What was 6.2?
Right, the trig expression of an algebraic expression.
I gotta do that. Okay, he says it's on the handout. Okay, read that to me and we'll try to close down with this. Then we'll call part 3.
Sine of inverse cosine mu.
Whoa. Sine of inverse sine?
Cosine.
Inverse cosine. Of u?
Mm-hmm.
Oh, we're going to math 8. You know what? Did I place that on there? And what were the directions.
Write the given trig expression as an algebraic expression in U.
Oh, they want me to simplify this. I'm getting scared myself. Okay, well, let's simplify this. Okay, since I was doing some inverses, guys, before the break, can anyone tell me, as we close this down, you've done a beautiful job tonight. Chapter 6, picture, I'm just done. Can anyone tell me anything when you see inverse cosine u? What does that mean? What does it mean? Let me give you a hint. We saw before the break this. You know what that meant? That meant on the unit circle, what angle has for an x coordinate cosine? 1/2, right? Here they didn't give you a number to work with, like 1/2. They just gave you a u. Can anyone tell me the best way I could express, another way to express inverse cosine u means? I'll show you what this one means. This one meant this. What was it? It's cosine 1/2, guys. What was it? Pi over 3. Is that the cosine? Is that statement right there true? Is the x coordinate of pi over 3 1/2? Can anyone tell me what this means the best I can? They did not give me a number to work with, they give me a u. Any ideas? What's another way to say this, like I did this one, except they gave you a u to work with rather than a number. Just trying to get you to think a little bit before we close all this down. Inverse cosine u. Okay.
Pi over 4.
Whoa. When you say pi over 4, pi over 4, I'd like to give you a specific number to work with. So if I gave you, who said pi over 4? So if I gave you, rather than u, they just use a u. If I had given you, Jonathan, radical 2 over 2, your response would be pi over 4, you'd be perfect. So they said, in this case though, to close down tonight, they're saying, leave it open, don't give them a number. Leave it open and ask, what can you do with it, which is, they're calling it u. Inverse cosine u. And is that the way it's written on your paper?
Cosine x equals U.
Cosine is some angle, okay? Theta, I'm gonna call it theta, you said x, which is okay. It means that. It's like here, it meant this. Okay? I don't know what the angle is because I have a u. I don't know what's going on here. Now I'm concerned here. That's what that little part there means. Anything else? Glad we brought saved this to last. I'm going to show you the little time I have here. Is there a relationship, by the way, between sine and cosine? I see a sine staring at me and a cosine staring at me. What would you, as a good, clever student, think of? What relationship are you thinking if you see a sine and a cosine? Is there a relationship between the two? Or is there something you've seen in class that we've used that has a connection with sine and cosine? Now this is new. Is this true?